Good day, everyone. I'm Sir RJ Layson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about illustrating quadratic equation. Now, this will be our first lesson in the grade 9 mathematics first quarter, which is under quadratic equations and inequalities. So a quadratic equation is in one variable is a mathematical sentence of a degree 2 that can be written in the standard form ax squared plus bx plus c equals to 0, where your a and b and c are real numbers and your a must not equal to 0. So we need to note in the standard form a should be a positive real number. So we have here the quadratic equation ax squared plus bx plus c equals to 0. Though the ax squared now is the quadratic term, the bx we will call that one the linear term, and the c will be the constant term. Now we need to remember those quadratic term. Who is the quadratic term with the 2 degree? No, or to the power of 2 there, the linear term, the term which have variable with an exponent of 1, and the constant term will be the term the walang present na variable there. So examples of quadratic equation, we have x squared minus 6x plus 4 equals to 0, 5y squared plus 5y plus 1 equals to 0, 9x squared minus 25 equals to 0, and 1 half x squared plus 3x is equals to 0. So you need to remember, when you say a quadratic equation, the highest value, the highest exponent there must be 2, or the highest degree is 2. So we need to write each quadratic equation into the standard form, and then we need to identify the value of the a, b, and c and answer that question that follows. Now, before we proceed to that questions in the next slide, we need to identify first here the values of a, b, and c there. So we have here, diba, in the quadratic equation, we have ax squared. So we have x squared there. That means our value of our a is 1. And then we have bx there, the linear term. So that means our b here is negative 6. So that is the value of b. And then the constant term is c is equals to 4. Next, we have 5y squared plus 5y plus 1. That means our a is 5, our b is 5, and our c is positive 1. Next, we have 9x squared minus 25. So we have here a as 9. Our b, since we don't have a linear term here, so we need to write that one is the value of b is 0. And your constant term is negative 25. Next, we have 1 half x squared plus 3x is equals to 0. Our a is 1 half, our b is 3, and our c is 0. Next, we have 3x minus 2x squared minus equals to 7. So we need to know our goal in the quadratic equation, the standard form, the right side must be 0. So we need to find ways, or we need to change this one, or to simplify this one by using subtraction property of equality. So we need to subtract 7 in the left side so that we can have 0 later on. And then when you subtract a value of negative 7 or minus 7 in the right side, you need to subtract also in the left side based on the subtraction property of equality. So we have 3x minus 2x squared minus 7 equals to 0. So we need to multiply, since our a there is negative, real number. So we need to remember in the previous slide that the a must be a positive real number. So we need to multiply both sides, the left and right side of the equation, by negative 1. So negative 1 times negative 2x squared, we have positive 2x squared. Negative 1 times 3x, positive 3x, that equals to negative 3x. Negative 1 minus negative 7, we have positive 7, and then equals to 0. So we have our a now is 2, b is negative 3, and c is equals to positive 7. Next slide, we have y squared plus y equals to 10. Again, we need to rewrite this one into the standard form of quadratic equation. So we need to subtract both sides by 10. So we have y squared plus y equals to 10, minus 10 equals to 10 minus 10. So we have here y squared plus y minus 10 equals to 0. So now we can identify the value of a. We have 1, the value of b 1, and the value of c is negative 10. Next, we have 5z squared equals to negative 8. So we need to our goal here is to rewrite this one first into the standard form quadratic equation. So in the right side, we must have 0 there. So we need to add 8 both sides to eliminate negative 8 in the right side. So we have here 5z squared plus 8 equals to 0. So we have 5 as our a. Since we don't have a linear term there, so we need to write b equals to 0 and c is equal to 8. And we have next 8x squared equals to 1 over 5x. So we need to subtract both sides by negative 1 5x, so that our goal there first is we need to have a 0 value in the right side. So we have now 8x squared minus 1/5 x equals to 0. So our a is 8, our b is negative 1/5, and c is equals to 0. So we need to rewrite the quadratic equation in the standard form and then identify the values of a, b, and c. Answer it and answer the question that follows. So here we need to simplify first the left side terms by distributing 4x times x, 4x times negative 5. So 4x times x, we have 4x squared. 4x times negative 5, we have negative 20x is equals to 9. Subtract both sides by 9 so that we can have 0 in the right side. So we have here 4x squared minus 20x minus 9 equals to 0. So we can now identify the value of a, b, and c. Our a is 4, our b is negative 20, our c is negative 9. Next, we have here, again, we need to simplify first the values in the left side by distributing 5x in each term. So 5x times x, we have 5x squared. 5x times 6, we have 30x equals to 2 over 5ths. So we need to subtract both sides by negative 2/5. So we have here now 5x squared plus 30x minus 2/5 equals to 0. So the value of a is 5, b is 30, and c is negative 2/5. Now here in the next example, we have a 2 binomial here. So what will we do? If you have a 2 binomial, we need to use the FOIL method. So multiply the first term first. 2y times y, we have 2y squared. Next, the 2y times negative 1, we have negative 2y. 5 times y, we have 5y, and 5 times negative 1, we have negative 5. So we have 2y squared minus 2y plus 5y minus 5 equals to negative 6. So we need to simplify first the value in the left side. So we have negative 2y plus 5y, since they have the like terms here. So we have 2y squared plus negative 2y plus 5y, we have positive 3y minus 5 equals to negative 6. Now our goal here is we need to have 0 in the right side. So we need to add both sides by 6. So we have 2y squared plus 3y minus 5 plus 6 is equals to 0. So we have 2y squared plus 3y, negative 5 plus 6, we have positive 1 equals to 0. So the value of a here is 2, b is 3, c is 1. Again, in here, we will need to use FOIL method. So x times x, x squared, x times negative 7, negative 7x, 7 times x, positive 7x, 7 times negative 7 is negative 49, equals to negative 3x. So we need to simplify this one. Negative 7x plus 7x, we have 0. So we have x squared minus 49 equals to negative 3x. So we need to add both sides by positive 3x. So we have x squared minus 49 plus 3x equals to 0. So our A is 1, B is 3, and C is negative 49. So let's think about this. Consider 5x squared minus x plus 10 equals to 0. What is the value of A in the equation? So we have A is 5. The B, we have B is negative 1 and C is positive 10. If A is equals to 0, will the equation still be quadratic? Of course, if your A or your quadratic term will be 0, so the result will be 0, so of course, no. Again, based on the definition of quadratic equation, the highest degree must be 2. Okay? We need to remember that one. If your B is equals to 0, will B still be a quadratic equation? So of course, yes. No, even though if the linear term will be equal to 0, but still you have the highest degree of the given quadratic equation is 2, yes, it can be still a quadratic equation. And then if C is equals to 0, will the equation still be quadratic? The same with the linear term. If you don't have a value in the constant term, but you must have a value in the quadratic term, or the highest degree must be 2, so of course it can be considered as quadratic equation. Again, thank you so much for watching, guys. I hope that you've learned something about this lesson. Please don't forget to like, subscribe, and if you have question, you can comment down in the question box. You can share it with your friends, and thank you so much. God bless everyone. Goodbye.